All right, my friends, the backwards chain rule. This is U substitution. And here's the gist. We know how to find these, right? You might need to use your sheet. That's totally cool. But I have like a formula for how to find the antiderivative of x to the fourth. I have a formula. I'd have to rewrite this one as x to the negative 3, but I could do that. I even have a formula for when it's like sine of 4x. But I do not have a formula for any of these pink ones. But we're going to be able to solve all of these pink ones. We won't be able to solve everything, but we're going to be able to solve these pink ones. So here's what you're going to look for. We want whatever would, and when I say it's like the function, to be the result of the chain rule. So as a reminder, the chain rule is when you have a function within another function. And the long and the short of it is the derivative of this thing would be derivative of the outside, we'll leave the inside alone, multiply by the derivative of the outside. So let's look at a couple examples. Here, this is going to be your f prime. This is your g. This is your g prime. And really the important thing is that the derivative of x squared is 2x. I'm going to be able to solve this problem using U substitution. Same thing, I'm going to be able to solve this one. Now this one's a little bit less obvious, but here's my f prime. Here's my g. And important to note, this isn't quite g prime. Like g prime would just be 3x squared. But the important bit is the x squared. Oops, wrong thing. My bad. The important thing is the x squared, and I do have the x squared here. So this is gonna work. And somehow in here, this is gonna be my g-ish. I'll put a little kind of sort of my g prime of x. Okay, now we're not gonna be able to solve everything. So for example, this one down here, we're not going to be able to solve this because my outside function would be this one. My inside function is here, but my derivative of 4x cubed, it's going to be an x squared, and there is no x squared, so this one I'm not going to be able to solve, at least with this method. Okay, so we're going to go through how to solve this one and this one, which are the same as the last screen. I'm going to move this guy out of the way first. Here's what we're going to do. I'm going to rewrite this as the cosine of u and leave everything else the same. That means that u is equal to x squared. Next thing I'm going to do is I'm going to take the derivative here, which is 2x. And I know this sounds kind of strange, but what I need is I need this relationship. I need a relationship between du and dx. Because what I'm going to do is I'm going to multiply both sides of this by dx. And I'm going to get du is equal to 2x dx. And this thing, this symbol, this multiplication, this it's Friday afternoon, I'm so sorry. This equal sign means is the same as, which literally means that du is the exact same thing as 2x dx. So this right here can get replaced with du. So I have the integral of the cosine of u du, and y'all know what to do in that case. The antiderivative here is just sine of u plus c. And then you know what u is because you already wrote it down. So it is the sine of x squared plus c. And if you want to double check by finding the derivative of this thing, you're going to get this. That's example 1. Well, let's do example 2. In this case, we're going to make this 15x squared. My u is going to be x cubed minus 4. du dx is then 3x squared. And in this case, I'm going to do a little bit more over here. I'm going to multiply by dx, which would get me du equals 3x squared dx. I'm going to divide by 3x squared, and that would give me that dx is the same thing as du over 3x squared. And now this is the same as here, so I can replace that dx. I can just say the integral of 15x squared u to the 4th is du over 3x squared. And the reason that I like this is that x squared is going to simplify. That's the beauty of this whole u substitution thing, is that that is going to take care of it. And then this 15 and 3, that's just going to give me 5. So I now have the integral of 5 u to the 4th du. I know how to solve that because this is just the antiderivative. And so I'd get 5 times 1/5 u to the 5th plus c. Right here, 5 times 1/5 is just 1, and so I'd get u to the 5th plus c, which means x cubed minus 4 to the 5th plus c is my antiderivative. Okay, and the other thing that we talked about was the fundamental theorem of calculus. And it is, for a continuous function, the area between a curve, the x-axis, x equals a, and x equals b, is the antiderivative from a to b of f of x dx equal to capital F of b minus capital F of a, where capital F is the antiderivative. This is a very long way of saying just a definite integral. Basically what this is talking about. We talked about this the other day. This is a definite integral. So here's the example that I had a while ago of, like, I'm driving a car and it's very boring. For 3 hours, I just go 30 miles an hour. So I know I'm gonna total of trip is 90 miles. That's the total of what my trip was. Well, this blue function right here is a very boring function. It is the function y equals 30. It's just a straight line, just y is equal to 30. The way that I would do this as an integral is I would say the integral from 0 to 3 of 30 dx, and that would be equal to 30x, because the antiderivative of 30 is 30x. If you took the derivative here, you just get 30. And what I'm going to do is I'm going to evaluate this from 0 to 3. And that will look like 30 times 3 minus 30 times 0, and you will get 90. Now you'll notice I left some big empty spaces for myself. We forgot about adding here our plus c, but if you add a plus c and you add a plus c, all that would end up happening is that the c's would simplify, which is why you don't actually have to use the plus c when you are doing a definite integral. Let's look at one more example. Let's say I have the curve x cubed, that's this pink line, and I just want to know what's the area between 1 and 3. So this is my a, this is my b. So the integral that I would write is the integral of x cubed from 1 to 3 dx. Well, the antiderivative is going to be x to the 4th over 4 plus c, but we're going to evaluate that at 1 and 3. So first I'm going to plug in 3, and then in the second version I'm going to plug in 1, and then we're just going to evaluate. And I didn't include my plus c because plus c here minus a plus c over here would simplify. What we'd end up with in this case is 3 to the 4th is 81 over 4, minus 1 to the 4th would be 1 over 4, which would get me 80 over 4, which is 20, and you are totally welcome, encouraged even, to use something like Desmos to evaluate this, and you will also get an answer of 20. Let me know what questions y'all have.